So in this video what we will see is, we will see about the relationship that arrays has with pointers. Okay. So to demonstrate that, I will declare an array and I will initialize them with some numbers. So let's say I will declare an array of 4 elements. So as numbers I will use 12, 15, 14, 26, right? Now we all know if you want to print any element of an array, we just have to do %d is the identifier, call the array and use the index. 0 will give me the first number. Okay, simple. Now what I am going to do is, instead of printing this, I will try to print with the identifier %p we know, which is used for identifying pointers, and I will just try to print the value of num. So num is nothing but the name given to array without the index, right? So let's say what it is printing. Let's see what it is printing. So it is giving me an hexadecimal number. The number is not proper because I am using an online IDM compiler. If you use a compiler like Linux or using code blocks, you will get a better number. So basically it is also giving me a memory location. So that means this is also a pointer. It is also storing a memory location. Okay. So let us see whether I will be able to store that address to a pointer. So let's say I will create a pointer address and I will try to give address and assign num to the address, right? Because I told you this num without this index of an array is nothing but similar to a pointer. It is a pointer, it stores a memory location. So address and num should behave in the same way. So now let us see, let us try to find out. Okay. Let us see what I will get when I dereference this address, this pointer. So I will use %d because it is integers. I am going to dereference address. What is the output? We will just see. Oh, 12. It is giving me 12. Now what is 12? 12 is the first element in this array. So basically address is storing the location of the first element. So that is what is happening here. Okay. So num, also address, both are pointers, and simple num, it is just storing, it is actually storing the location of the first element. Now is there any way to get the second element? There is. To do that we have to use what is known as a pointer arithmetic. Okay, so I'll show you how it is done. Printf %d and you use dereferencing. But the only thing is I will dereference address +1. I'll run this. So it is giving me 12 and 15. So I'll give a tab here so that it is more clear. So that means address is, or dereferencing address is same as I am writing num0. It is one and the same. It will yield the same result. Dereferencing address +1 is same as num of 1. Okay, so this is the pattern that we are observing. So basically if you want the third element, what you have to do? Same thing. Only thing is, so I'll give a tab space here. Address +2. We'll run this. So 12, 15, 14. So this is what is known as pointer arithmetic, and so we'll try to just understand this in a better way. So let's say I have a stack with lot of memory words. Okay, so this one word represent maybe 8 bits, generally 8 bits. Okay, these have an address. So when I declare one array, let's say array of two elements of integer type, so generally they will occupy 1, 2, 3, 4 is for the first element, 1, 2, 3, 4 is for the second element, 1, 2, 3, 4 is for the fourth element, and so on. So this is for num of 0. Okay. This is for num of 1. So num of 2. Okay, and address of this is what is stored in my address pointer. Okay, so when I do address plus 1, what is happening is it will see what is the type of data type it is. It is an integer, so that means I have to have 4 spaces. Okay, so it will add one address, the address of this, plus 4 times 4, because it is an integer data type, 4 times 1. Okay, so it will store this. So this is nothing but address plus 1. So because it is an integer database, it is skipping 4 places and taking the next address. If it is double, it will skip 8 places and store the next address. Okay, again, when I am telling 4, 8, this is generally the case, but some computers, some architectures may be 2, it may be 3, that depends upon the computer architecture. But generally, in integers take up 4 bytes, doubles take up 8 bytes. So that is why I am telling address will be the first. Address plus 1 will be, it will skip 4 spaces, and this space address will be stored here. So address plus 1 is nothing but address of this variable. So this we can go on doing like this and taking values of array. So this is one concept that I want you to get introduced. Basically, arrays is also nothing but a kind of pointer. The array variable name is basically storing the address of the first element of an array. Okay, and whenever you declare a pointer and assign this to this array, you get the location of the first element. Second element, third element, fourth element, all elements you can get by dereferencing the array arithmetic. Array arithmetic is you are basically adding numbers to the array 1, 2, 3. So adding numbers is basically, it depends upon what is the type of data type. If it is integer, it will add 4 spaces. If it is double, it will add 8 spaces, and so on. Generally speaking. So I hope this is clear. We will do some more of array operations with pointers in the next video. Thank you.